I wouldn't.
All right, triangle trig, guys. Remember trig functions? That's right. So, hey, sine of r or sine of an angle is what's definition? That's right. Opposite over hypotenuse. Cosine. Adjacent. And opposite over adjacent. Okay, find sine of A, cosine of A, and tangent of A. Express each ratio as a fraction and add decimal to the nearest hundred. Okay, so they want it from the viewpoint of angle A. So the sine of A is from the viewpoint of A is opposite, adjacent, and hypotenuse is longest side or always opposite the right angle. Sine of A is going to be opposite over hypotenuse. And they want that expressed as a decimal. Nope, not yet. 0.38. Cosine of A is going to be adjacent over hypotenuse. Decimal. And tangent is opposite over adjacent. Well, it says 100. Opposite over adjacent. Okay, for the rest of them, we got to find sine of J, cosine of J, tangent of J, sine of L, cosine of L, and tangent of L. Yep. Okay, so sine of J, cosine of J, tangent of J. Then we've got cosine of L. Oh, this should have been the sine. That's okay. Sine of L and tangent of L. Okay, so from the viewpoint of angle J, this is going to be my opposite, adjacent, and hypotenuse. Okay, sine is opposite over hypotenuse. Reduce before it goes into 12, 3 times. 3/5. Bless you. Bless you. Cosine of A is adjacent over hypotenuse. 4 goes into 16, 4/5. Tangent of J, opposite over adjacent 3/4. Cosine is adjacent. Oh, from this one, from the viewpoint of angle L. This is my opposite. Hypotenuse stays the hypotenuse. The longest side is the side across from the right angle. Hypothesis. And my adjacent is this side. Okay, cosine of L. Adjacent over hypotenuse. And 12/20 was reduced to 3/5. Sine of L is opposite over hypotenuse. And that reduces to 4/5. Tangent of L is opposite, 16 over adjacent, 12, which is 4/3. You guys see some patterns or similarities? Yes. Let's see. The sine of J is the cosine of L. The cosine of J is the sine of L. And tangent of J is the reciprocal of the tangent of L. Okay, I'm going to do number 3 for you because we're in Algebra 2 and we're big people now. We got to do things correct. Okay. Sine of J. So we're looking at J. This is my opposite, adjacent, and hypotenuse. Sine of J is opposite over my hypotenuse. Now, since we're big people now in Algebra 2, what can we have in the denominator? That's right, a radical. So we need to get rid of the radical 3. I think I'm going to reduce my numbers first. 12 can go into 36 3 times. 12 can go into 24 twice. I have to get rid of my radical 3. So I'm going to multiply by radical 3 over radical 3. So this becomes 3 times radical 3 over 2 times 3. So this becomes 3 radical 3 over 6. I can still reduce my numbers. 3, 6 is 1/2. So I have radical 3 over 2. Isn't that fun? That's more funner. Hey, cosine of J. What? I have no idea what you're talking about. No, that would be an approximation. We have to do exact numbers. We are people now. No approximation. Hey, cosine of J. Cosine is going to be adjacent. 12 radical 3 over hypotenuse, 24 radical 3. Hey, you know what? We can do this easier. 12 goes into 24 how many times? Okay, radical 3 over radical 3 is what? So what do I end up with? Or we could do it the long way again. Sure. A tangent of J equals opposite, because 36 over adjacent, which is, well, radical 3. 12 goes into 36 3 times. Uh-oh, this one we can't cancel out the radical 3. Okay, this one we're going to have to do it the long way. Multiply radical 3 over radical 3. So I get 3 times radical 3 over radical 3 times radical 3 is 3. Now I can cancel out the 3's. And I get radical 3. Okay, but this one's easy. L. From the viewpoint of L, this is my opposite. This is my adjacent. And hypotenuse is always the hypotenuse, can't change. Now, let's look at our pattern from the previous problem. The sine of J was the same as the cosine of L. So the cosine of L is the same as the sine of J, which is radical 3 over 2. The sine of L was the same as the cosine of J. The cosine of J was 1/2. And the tangent of L was the reciprocal of the tangent of J. So the tangent of J was radical 3 over 1, so this is 1 over radical 3, which we multiply by radical 3 over radical 3, becomes radical 3 over 3. So it wasn't so bad. Which one? Right here. What? That's part 1. Ready? As Bob Seger and Metallica would say, because they did a re-thing of what do you call it? They did the song to turn the page. A remake. Hey, turn the page. Everybody remember how to find the sides? Okay, round to the nearest tenth, so we're going to do calculators. Set up a trig function. Trig's our trig function, sine SOHCAHTOA, right? SOHCAHTOA. Huh? What? Opposite hypotenuse, adjacent hypotenuse, opposite adjacent. Okay, you ready? Let's see, set up a trig function, use so they give us angle measurement 64. So whatever angle they give you, That's the angle is the viewpoint from. Okay, again, hypotenuse is always the hypotenuse, doesn't change, but the viewpoints do change on the angle. On this particular one, X is going to be my opposite, and the 11 is my adjacent. Okay, so they gave us the opposite and adjacent. Which trig function am I going to use? Up here, see which one is opposite and adjacent. And 64 degrees, that's given, equals, yep, opposite, which is X over 11. Now we're supposed to solve for X. Yes, we are going to use your calculators, but since we have a ratio equals a ratio, because we can make this a ratio by putting it over 1, we can do cross multiplication. 11 times tan of 64 degrees equals X. What's the first thing you're going to do with your calculators here? No, 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 no. Make sure it's in degree mode. Because I would mark it wrong, because I'm not going to catch it if it's in radian mode. And trust me, your classmates like to put things in radian mode just to mess with the other classes. Okay? I'm sure you will. Okay, so you're going to take 11 times tangent 64, and you get 22.5. We're supposed to round to the nearest tenth. 22. Now, notice here that my X is in the numerator, right? When it's in the numerator, I multiply to the trig function. Yeah, I mean, it makes sense that if my X is in the denominator, you're going to divide by the trig function. Okay, you ready for some example problems? Okay, first example. They give us, oh, by the way, we'll get to it next time. That's right. All right, angle A. They give us angle A. From the viewpoint of angle A, they give us the opposite side and the adjacent side. So what trig function am I going to use? Same one, tangent 36 degrees equals opposite over adjacent. Where's my X? The top. So I'm going to multiply 7 times the tangent of 36. And what do I get? 5.1. That makes sense. 5.1. And I'm going to do the third one. From the viewpoint of the given angle, they give us adjacent and hypotenuse. Which trig function am I going to use? Not tan. Huh? So, Katoa, come on, which one has adjacent and hypotenuse? Cosine. Cosine of what? Oh, I didn't hear you. Cosine of 41 degrees equals adjacent over hypotenuse. From the viewpoint of the angle, this is next to it, and the hypotenuse is always a hypotenuse. Okay, longest side across the right angle. Okay, my x is in the numerator, so what am I going to do? Multiply, and what do I get? Let's do the second one. Okay, from the viewpoint of angle W, I have opposite over hypotenuse. What trig function am I going to use? Sine opposite over hypotenuse. Where's my x? Bottom. So what am I going to do? I'm going to divide by the trig function. And I get 13.5. Okay? No, you get the point. Yes. Okay, guys, remember angle measurements? Okay, they give us angle T. They want us to find the measurement of angle T. This time, they give us the length of two sides. Okay, you can't do this without the length of two sides. Now, from the viewpoint of angle T, we have the opposite over the hypotenuse. So, which trig function am I going to use? Sine. Okay, opposite over hypotenuse. Now, I will try to be consistent and use x for my angle measurement. I'll say x degrees. You're probably going to see me use theta a lot because that's how I was taught. Yeah. You will probably see, even if I say x, I may even write down theta. So please, been warned. Well, they give it to us. Okay, so all of these are the same. Okay, so I'll try to use x. Okay, so we're going to use the sine of x. The sine of x degrees equals opposite over hypotenuse. And to find x, we're going to take the inverse of the trig function of the fraction. Okay, and you're right. You're going to use the second key, and then sine. Make sure you get the little -1 in there. And you're going to put in your 29 divided by 34. Use the second key, and then hit sine. Okay? Second key, then sine. What? Wow, what a loser. I'll do an example. Number 5. Number 1. I did it wrong. 5. Oh. Okay, number 1. From the viewpoint of angle T, this is going to be our opposite and adjacent. I'm going to use tangent. If I call this x degrees, is opposite over adjacent. So x degrees tangent inverse of 14 radical 3 over 34. Okay, here we go. And, yep, 14 radical 3 divided by 34. 35.5. 35.5 degrees. What else you got? You got some Trig word problems there. Okay, example 1. These are easy. Step 1, read the problem carefully. A boy is flying a kite, lets out 300 feet of string, which makes an angle of 52 degrees with the ground, assuming that the string is stretched out. Find to the nearest foot how high the kite is above the ground. So with trig, right triangle trig problems, application problems, what are you going to have? That's right, a right triangle. Okay. Boy, yeah, it's fine. Well, you draw yours different. A boy was flying a kite, lets out 300 feet. So that's my hypotenuse. Makes an angle of 52 degrees. So it's my 52 degrees to the ground. Assuming the string is taut, find the nearest foot, how high. So we're looking for the height. See, from the viewpoint of this angle, I have opposite over hypotenuse. That is a sin, a sine of 50 equals opposite over hypotenuse. My x is in the numerator, so what am I going to do with the 300 and the 52, sine of 52? Multiply. About 236.4. Okay, I got this flagpole. 40 feet high. cast a shadow, 30 feet long. Find to the nearest degree the angle which makes with the ground. So we're looking for this angle. From the viewpoint of this angle, we have opposite over adjacent. Here's tangent. X degrees equals opposite over adjacent. We're looking for the degrees of an angle, so I'm going to use the inverse. See, second and 40 divided by 30. I get 53 point. I use 4/3. 40 over 30. They cancel. And I get 53.1. Nearest degree. So actually. Okay. You do the rest of the problems I didn't do.